This is the Module 1.7 RSG, the homework section, and I think it's a really great opportunity to practice the skills for this unit that will be on the test. So I'm going to do some problems in this video that are not on the formative so that you can practice on your own when you get to the formative. So let's start with number 1. The directions say find the missing values for each arithmetic or geometric sequence. Underline whether it has a constant difference or constant ratio. State the value of the constant difference or ratio, and then indicate if it's arithmetic or geometric by circling the correct answer. So we're looking at this first sequence, and it goes 5, 10, 15, blank, 25, 30, blank. And so I have to figure out what's happening between 5 and 10, 10 and 15, and this one sounds a lot like skip counting, so I'm thinking it's adding by 5. So this space would be 20, 25, 30, 35. And since it's adding 5 each time, then it has a common difference. And that common difference is plus 5. And since it's adding, it's arithmetic. So all of these are just identifying the pattern, filling in the gaps, and then remembering that arithmetic sequences have a common difference and geometric sequences have a common ratio, and then write what that action is. So this is that action piece. So that's the first half. In the set, we're also doing some really great practice. It says determine whether the given information represents an arithmetic or geometric sequence, then write a recursive and explicit for each equation, which is also excellent practice for the test. So I'm going to do number 5 with you. And it says, let's see, from 2 to 4, I could be adding 2 or I could be multiplying by 2. But from 4 to 6, that's not multiplying anymore. It would be, so this is adding 2. 2 plus 2 is 4. 4 plus 2 is 6. 6 plus 2 is 8. So that's arithmetic because it's adding, and the recursive is f of n equals f of n minus 1 plus 2. F of 1 equals 2. And that f of 1 equals 2 piece is just saying, since this is a sequence, the first term in the sequence is 2. So this is one of those ones that starts at, the starting input is 1. So in my explicit, and it's going to be, starting with 2, I add 2 n minus 1 times. And it has that minus 1 because the pattern starts at 1. If you wanted to be fancy and work backwards to 0, it would actually start at 0. And what I mean by that is we already know that the first term is 2, and the second term is 4, and the third term is 6. So we could make the table go backwards and say, well, the 0th term is going to be 0. So if I want to go back to 0, then I would say f of 0 equals 0, and I'd get f of n equals 0 plus 2n. So both of these equations would work. This one is just that shorter, cleaner, faster version. Either of them would be marked correct on the test. And then let's go ahead and do number 8. So this one, I get to see what's happening, how's it growing, and I could say 5 plus 3 is 8, but 8 plus 3 is not 12, so it can't be adding, so we've got to be multiplying, and it looks like we're multiplying by some weird numbers because we've got decimals down here. So here's a trick for how to find the common ratio. We already know it's not adding because we tried to add and it's not the same number each time. So I can work backwards and divide. So I'm going to take 20.48 and I'm going to divide it by 12. I'm going to use my calculator on my phone for that. .48 divided by 12.8. And that gives me, when I divided that, I got 1.6. And then to make sure that that works each time, I'm going to try it again. Now I'm going to do 12.8 divided by 8. And I get 1.6 again. And just to double check, you can just keep doing it with each pair of numbers. 8 divided by 5 is also 1.6. So that tells me that moving forward, the common ratio is 1.6. And so that makes it geometric because I multiplied by 1.6 each time. So my recursive is going to be f of n equals f of n minus 1 times 1.6. F of 1 equals 5, which means the very first output was 5, and since it starts at 1, I'm probably going to have n minus 1 in my explicit. F of n equals, starting at 5, I multiplied by 1.6, and then to the power of n minus 1. Make sure you have an exponent in a geometric. If you wanted to go and be fancy-pantsy and move your table and include 0 so that it could be shorter and you wouldn't have to have that n minus 1, you could take 5 and divide it by 1.6. And you would get 3.125. And so this is how I could make my equation shorter in the explicit, and I could say f of n equals 3.125 times 1.6 to the power of n. And the only thing it helps me with when I go back to the 0th input is that my exponent is just plain n and it doesn't have that n minus 1. Both of these are correct. Either one would be correct on the test. And so the very last section is practicing a new skill. And if you look on the formative, there's a great video that's helping you find the slope. But basically, you want to plot these 2 points. So this is -2, so x goes left to right, so negatives are left. And then y values go up and down, so this goes up since it's positive. I'm going to take my cursor here, and I'm going to go left 2, up 1. And that's my first point. And since the second set, I have x is a positive 2, which means I'm going to go to the right 2, and y is a positive 5. I'm going to go up 5. So I'm going to go to the right 2 and up 5. 1, 2, 3, 4, 5. So I have my 2 points, and they want me to find the slope. And slope is rise over run. So how many does it go up? And how many does it go over? So the rise is 1, 2, 3, 4. I have those backwards. It goes up 4 and over 1, 2, 3, 4, and over 4. And 4 over 4 equals 1. So slope is 1.